welcome once again to another lesson of mechanics. In this lesson, we talk about the law of the conservation of energy, in particular mechanical energy. This law states that energy cannot be created or destroyed. It can only be transformed into other types of energy. The total amount of energy in a system is constant. Written another way, mechanical energy initial is equal to mechanical energy final, where I represents the initial and F represents final. ME represents mechanical energy. But mechanical energy consists of potential energy, PE, and kinetic energy, KE. So you have to break this into two parts. PEI plus KEI is equal to PEF plus KEF, where PEI is the initial potential energy, KEI initial kinetic energy, PEF final potential energy, and KEF final kinetic energy. We can write ME is equal to KE plus PE, and previously we learned that KE kinetic energy was equal to half mv squared, so we can replace this KE with half mv squared here, and the PE was mgh, where in this case m represents mass, v represents velocity, g is your acceleration due to gravity, and h is your vertical height. So ME is equal to half mv squared plus mgh. Mechanical energy, as we said, consists of kinetic energy and potential energy. Now let's look at some examples on activity which uses these concepts. In this first activity, a block slides down a smooth hill of vertical height 120 meters starting from rest. What is the speed when it reaches the bottom of the hill? Now note that at the top of the hill, it is full of potential energy, but when it starts moving, it gains kinetic energy, gains velocity, and when it reaches the bottom of the hill, it has no potential energy, but it's full of kinetic energy. So between the top of the hill and the bottom, all the potential energy was converted to kinetic energy. So here, because of this conversion from all PE to all KE, we can say that PE is equal to KE. So the same amount of potential energy it had at the top is converted to kinetic energy when it reaches the bottom. So remember, the formula for PE was mgh, formula for KE was half mv squared, so we said mgh equals half mv squared, and we want to find its speed. So velocity is speed in a given direction. Speed is just the scalar amount from velocity with no direction. So the magnitude is going to be the same, or the amount will be the same. We need to find v, velocity. So then you want to make v here the subject of the formula. We start with multiplying both sides by 2. So we have 2 mgh is equal to mv squared. And then by dividing through by m, we have 2gh is equal to v squared. And then solving for v, we have v is equal to the square root of 2gh. Now we're going to substitute the numbers that we have So we have V now is equal to square root of 2 times 9.8. 9.8 is what we use for acceleration due to gravity, times 120, which is a height, vertical height. So that's equal to the square root of 2,352. The square root of 2,352 is 48.5, rounded for 1 decimal place. So the speed of the block when it reaches the bottom of the hill is 48.5 meters per second. Now let's look at another problem, another activity. Here it says a 6 kg block compresses a horizontal spring with a spring constant K is equal to 250 N over M by 2 meters from its natural length. Hint here is that the spring potential energy is given by the formula half kx squared, where x is the displacement, and of course it tells you k here is a spring constant. So it's half spring constant times displacement squared. We're asked to find what is the speed of the block as soon as it is released from the spring, and how high up the hill. We're not told about a hill in here, so we assume it's just going upwards, but it says up a hill here. Where the block go? So let's look at the speed. So all this spring potential energy is converted to kinetic energy, so P is equal to KE, and we said the potential energy here was half kx squared. We set that equal to half mv squared, which is a formula for Ke. And so if we multiply both sides by 2, kx squared will equal to mv squared. And if we want v only on one side, v squared is going to be equal to kx squared over m. And then taking square root, both sides, v is equal to the square root kx squared over m. Then we substitute for k and x. We have v now equals the square root of 250 times 2 squared over 6. And that's equal to the square root of 1,000 over 6. That is equal to 12.9. So the speed there will be 12.9 meters per second. Part B, we're asked to find the height or the h, so we're going to set mgh now is equal to half mv squared. And so solving for h is equal to mv squared over 2mg, but we can divide the m's into each other, so h is equal to v squared over 2g. And so substituting numbers, where v we got was 12.9 from above, so we plug in 12.9 squared at the numerator, and then 2g is 2 times 9.8, where g was the acceleration due to gravity, which we take to be 9.8. Solving that gives you h is equal to 8.5 meters. So the block will travel up the hill, it's as I said, 8.5 meters. Let's look at the third example. Activity 3. A 12 kilogram block slides down a hill, 150 meter vertical height, with an initial speed of 10 meters per second. So notice here, this one begins with an initial speed, whereas the others, started from rest. So your initial speed is 10 meters per second. It says, what is the speed at the bottom, assuming there's no friction? So then we're going to use, because we're given an initial velocity, we have to use that. So a good formula to use is v squared is equal to u squared plus 2as. But in this case, we're using gravity as our a, and your s, your displacement is h. So V squared is equal to U squared plus 2GH. Plugging in the numbers that we got, we had an initial velocity of 10, so that's 10 squared, for U squared is 10 squared, 2, and G is 9.8, and H was given as 150, so 10 squared is 100, 2 times 9.8 times 150 gives 940, so this will be 100 plus 2,940, that gives you 3,040. That was V squared. Now V is the square root of 3,040, so that would be equal to 55.1 meters per second. So the speed when it reaches the bottom will be 55.1 meters per second. Now for part B, if the block travels 400 meters with a coefficient of friction, mu is equal to 0.8, what is the final speed? So there's friction now associated with this, so we have to calculate the energy which friction takes away, or the work done by friction. So the work done by friction is mu times mg times the displacement, mgd, and the distance was given as 400, mu was 0.18, m was 12, and g is taken to be 9.8. Multiplying those together gives you 8,467.2 joules. As you know, this work is in a negative direction, or the opposite of the movement of the object. Then working out the initial kinetic energy, because we were given an initial velocity. That initial kinetic energy is half mv squared, or if you wanted to use u, that's fine for your symbol for your initial velocity. And that's equal to half times 12 times 10 squared, that gives you 600 joules. Now that's the kinetic energy. Then we have potential energy, which is converted to kinetic energy, which is mgh. M was 12, G was 9.8, and H was 150. 12 times 9.8 times 150, that gives you 17,640 joules. So then the net energy here, or what you would call the final kinetic energy, it will be the sum of the potential energy converted to kinetic energy, 17,640, plus the initial kinetic energy, which is 600, minus the work done by friction, or the energy taken away by friction, if you want to call it that. It's 8,467.2, and so your final kinetic energy is going to be 9,772.8 joules. But our question is to find the final speed, or final velocity. So then we got to set this equal to the half mv squared. So half mv squared is equal to the 9,772.8 joules here. And then we're trying to solve for v. We know m was 12 and a half there, so 6v squared would be equal to 9,772.8. So we divide by 6 and then take the square root. So v would be equal to 2 times 9,772.8 divided by 12. Okay, or it would just be 9,778 divided by 6 either way, and the square root of that gives you 40.4 meters per second. So the final speed is 40.4 meters per second. Thank you.